Hey guys, welcome back to another video. Today we're going to be going over a pre-calculus topic that was brought up to me by a student, essentially prepping for a test. This test comprises of mainly inverse functions, polynomial functions, a little bit of end behavior graphing, things like that. So without further ado, let's get to it. All right, so the first question gives us this function right here and asks us to find the domain, the range, the axis of symmetry, and put this into standard form. So first things first here is what we're going to talk about is the domain. Domain, for those that don't know, is basically the range of values that a function covers from left to right. So think about it as if like you're walking on the function, right? Let's say, for example, I make a little graph like this. Notice that if I walk across this function like this, right? What the domain is asking is there any point along this walk that I'm gonna have to stop, jump over to the other side, or am I gonna like fall off a cliff or something? So in this case here, notice that if I walk across it this way, or even if I go back down it this way, there's not a single place I have to stop. I can go on forever. That's why in this case, the domain is gonna be from negative infinity to positive infinity. But let's say a really popular graph of a rational function that looks something like this. Notice that if I'm going here and I'm walking across, I'm having a good day, I'm falling off a cliff. And then if I pick back up, I'd have to jump all the way back up here and then walk across. Same thing from the other direction. So in this case, my domain is gonna start from negative infinity because look at this, that arrow tells me it's going on forever. I can come back from as far back here as possible, but the second I hit here, 0, right? My x value is 0, I'm gonna fall off a cliff. So boom, I fall off, so negative infinity to 0. Then, don't worry, I pick back up, also known as union. Union's that pick back up idea to infinity. So, how do I find the domain here? Well, let's figure out what the parent function is. If I take out all these numbers, 3, 5, and 12, this just leaves me with x squared, which is a parabola. Now notice that the domain of a parabola, as long as it's either this direction or this direction, is gonna be negative infinity to positive infinity. The reason why is because domain is from left to right, and no matter what, these values are always gonna be increasing going outward. So in this case, it's gonna have to be negative infinity to positive infinity no matter what. Now the range is a little bit different. Range is the same idea, but up and down, right? So in this case, it's the same idea, but imagine like I'm propelling down. Is there gonna be a point where I can't propel down any further, or I'm at to like jump and then propel down from a different spot, right? That idea. For your typical parabola though, there is gonna be a place that you have to stop, which is known as your vertex. In this case, the vertex is down here, so it's a minimum value, but there's also cases where it's negative and it's a maximum. Our job is to figure out which. So what I'm gonna do is I'm gonna figure that out by using vertex form. In other words, a times x minus h squared plus k. The reason why I'm gonna use this is because this is the cheat code for any transformation of a graph. The reason why is because this k value tells you for any graph, no matter what, up and down, right? This is the vertical change. H is my horizontal change, and a is basically the change of the shape of the graph. In this case, my k value is plus 12, which means that my graph has been shifted up 12 units. That is dictating part of my vertex. And vertical, it's my y value. So I know that my y value has a vertex of positive 12. My h value here is 5. Notice that it says minus 5, but also notice that the equation has a minus. So this isn't minus 5, this is just technically 5, it's just the minus is included in the equation. So my vertex is 5, 12. Now I gotta figure out, is this graph going up or is it going down? That's my a value. Notice in this case that a is negative. Anytime that value in front is negative, it means it flips the graph over the x-axis, flipping it upside down, meaning my vertex is in fact a maximum. So with that being said, that dictates my range. So my range is going to be negative infinity, because notice this thing goes down forever, but stops at 12. So in this case, if I had to write my range, it's going to be negative infinity, comma, 12. And I put a close bracket there instead of an open one because 12 is actually included, right? 12 is the last possible point. It is included in that value. So this hard thing says it's included. Negative infinity is technically not included because there's not one definite answer, right? What close means is there's a definite end. Open means not a clear definite end. It's like an open-ended question, right? It's not closed, it's not cut and paste, like that's definitely it. There's some interpretation that can be involved. Now for axis of symmetry, well, shouldn't have erased that because we need it as well. Axis of symmetry is just, let me karate chop this thing in half. At what point is this thing cut in two? Well, I know that the graph has a vertex of 5, 12, let's just say that's there, and it goes upside down like this. Well, if I cut it in half, it's gonna be here, dictated by what? My x value. So my axis of symmetry is gonna be equal to x equals 5. The last thing here in this case is putting this out into standard form. Standard form is just factored out. So I'm gonna factor this thing out. This is a binomial squared, so it goes by a squared minus 2ab plus b squared. So -3 times a squared, so that's x squared, minus 2ab. So what I do is I multiply this term times this term. -5 times x is -5x, times 2 is -10x, plus b squared, so -5 squared is positive 25. From here, just simplify. I'm gonna multiply everything times -3, so -3x squared minus 30x minus 75. Actually, it's gonna be plus 30x because negative times a negative is a positive, plus 12. And then final thing here, I'm gonna combine like terms here, -3x squared plus 30x, and in this case, minus 63. And that's it for the first question. All right, second question, they give us a 0.25, a vertex for -3, and they want us to write it in vertex form. All right, well, we know that vertex form is this. And remember, I said that the only two things that can move a graph around, physically shift it, are h and k. So in turn, when it comes to a parabola, that is gonna be our vertex. Well, my y value is down -3, which means a vertical shift of -3. So that's gonna be my k value. And then my x value here is my horizontal shift. In this case, it's 4. So I'm gonna just replace h with 4. X minus 4a. So let's say f of x is equal to. We're close, we're close. The only issue is I don't have a, but that's what this point provides us. So very important rule in math is majority of the time, if you want to solve for something, you have to have that be your only variable, right? I can't solve for x and a if I don't know what x and a are, right? I'm left too much in the dark. What this provides us is it provides us the missing variables. It provides us with x, and it provides us with f of x in this case. If that's the case, that means a is the only variable, which allows me to find it. So what I'm gonna do is I'm gonna replace everything. F of x, 5 equals a times 2 minus 4 squared minus 3. From here, I just solve. Well, 2 minus 4 is -2, squared is 4. 5 equals 4a minus 3. From here, I add 3 on both sides. That gives me 8 equals 4a. And then the last thing here is I'm gonna divide by 4, inverse operations, leaving me with a equals 2. And so then from there, well, I'm just gonna take that knowledge and I'm just gonna plug it back here. And that gives me my final answer for that question. All right, here I didn't write the whole question on this board, but I'll have it posted probably like right here. But essentially what the question is saying, right here is a quadratic giving me this relationship between price and profit. And what it's asking us to do is find the maximum price that we can charge to make the maximum profit essentially. So the first thing I'm noticing here is this is a quadratic, right? It's a degree 2. So anytime you're trying to find the maximum of something in terms of a quadratic, what is that gonna be? Well, most likely it's gonna be your vertex, right? Because if I have an upside down quadratic, and right here, that is my absolute maximum value. Specifically, it's actually my absolute maximum value of x or of y given x, right? That's what a function is. It's your absolute output given a particular input. Well, that's exactly what it's asking us for. My input is my price resulting in my output, which is profit. So in other words, I just have to find the vertex. Now, in this case, we could put this into vertex form. That's 100% something we can do. But that's long, right? I gotta factor things out. I gotta complete the square. I gotta do a bunch of stuff. That's boring. Like, again, math caters to lazy people, and I'm lazy. I don't feel like doing that. So instead, what I'm gonna do is I'm gonna use this other idea, which is negative b over 2a. What that solves for is the x value of the vertex. And that's what we're gonna do here. So I'm gonna plug that into my formula, negative b over 2a. It goes in alphabetical order, so this is A, B, and then C. So B is 25,000, so negative 25,000, because it's negative B, negative 25,000 over 2 times A, which is negative 10,000. From here, I'm going to simplify and solve. So for starters, 2 times negative 10,000 is negative 20,000. And I don't have a calculator with me, so I'll show you how I would do this mentally. I see 3 zeros that are lining up with each other. That means they're irrelevant. So I got negative 25 over negative 20. Well, negative divided by negative is a positive, so negatives are also irrelevant. And then from here, I can just reduce. 25 and 20 are both divisible by 5. 5 goes into 25 5 times, and 5 goes into 24 times. So this is 5/4. But since we're dealing with price, we should probably put it into decimal value. So 4 goes into 5 one time with 1 remaining, and 1/4 is the same thing as 0.25. So my maximum price in this case is 1.25. Now, in order to find my maximum profit, remember this is a function, right? What this function is telling me is it's giving me an infinite set of outputs depending on my input provided. But it doesn't want to assume what input I want to provide, so we just replace that with x. It's just saying, hey, whatever you want to put in for x, be my guest, I'll give you what your answer is. So in this case, my input is 1.25. So I would just plug that into my equation. This is a calculator question. So, I mean, all you'd have to do is 1.25 squared times negative 10,000 plus 25,000 times 1.25 minus 12,000. And that will give you $3,625. All right, on to the next one. All right, next one here, I got f of x is equal to 3x squared plus 6x squared. The question's not asking me anything in terms of solving, it just wants some stuff from us. It wants the leading coefficient for one, it wants the degree value, it wants the end behavior, it wants the number of possible turning points, and the last thing it wanted was the y-intercept. Now, in terms of this is actually something that we don't have to use any pen and paper for, right? That was a lot of questions, but actually we don't need them. I'll show you how. So, when it comes to describing end behavior is technically just y value, right? It's basically saying if I push this thing as far to the left and far to the right as possible, is it going up or is it going down? That's all it is, right? So think of end behavior as y. I'm just trying to think of when it goes up and when it goes down. Before we get to that though, leading coefficient, it's just the first number. So in this case, leading coefficient is 3. So LC equals 3. All right. Next thing here, highest or the degree value. In this case, when it's in standard form like this, it's not factored out. It's just the highest degree value, which is 3. So the degree in this case is also 3. That is a coincidence, right? That doesn't happen every time. It just happens in this case. Next thing is this end behavior. So the way that end behavior works is it's just saying as x is, it's almost like a limit, right? So I can write it as a limit, for example. So the limit as x is approaching negative infinity. So in other words, as this graph is going left, what is it doing? And the other part of the limit is as x is approaching positive infinity. What is f of x equal to for both of these? No math involved. So what I'm going to do is I'm going to give you this. There are 4 possible ideas for end behavior. There is up, up, meaning that it starts going up and it ends going up, right? The other one is down, down. In other words, it starts going down, it ends going down. The next one is down, up. It starts going down, but it ends up going up, right? Starts down, ends up. The other one is down, up. So our up, down. Starts up, goes down. Now, in terms of up, up, and up, down, these are both positive, meaning that the leading coefficient, my A term, look, we're back to that vertex idea, has to be positive in order for it to be either of those. In this case, down, down, these are negative ideas, right? That A value, that leading coefficient in this case, is going to be negative. So it's going to be one of those two. Now, for it to be up, up, or down, down, in other words, they are going into the same direction, or they're both going the same direction regardless of what side it is, that's an even idea. So in this case, this is even. All of these. Now, if it's going down, up, or up, down, that's an odd idea. Now, what do I mean by all this? Well, let's do it based on this. The first thing is it positive or negative? Like I said, it's that leading coefficient or A term. Well, my leading coefficient today is 3. That's positive, meaning that it's either going up, up, or down, up. It's got to be one of those two ideas. Now, even or odd is referring to the highest degree. In this case, we're degree 3, meaning that it has to be going down, up because it's odd. If this was degree 2, right? Let's say, for example, 6x squared was my highest value, then it would be going up, up. So as long as you remember these 4 ideas here in that order, you can always figure out end behavior because those are the only 4 possible ideas here. In this case, it's going to be going down up. As x is approaching negative infinity, right? This is my first value. It's going to be going down because it's down up. Now here, exact opposite. It's going to be going up. Turning points. Turning points is just one below the exponent. In this case, it's degree 3, so 3 minus 1 is 2. So our turning points is equal to 2. Very important to note here though. That doesn't mean it necessarily turns twice. It means the maximum value it can turn. So let's say, for example, this is degree 5. It doesn't mean it's going to turn 4 times. It means it can turn up to 4 times, but it doesn't always have to. Very important distinction. Last thing here was the y-intercept. Well, if you think about a graph, my y-intercept is here. What do all of these have in common? Well, they all have an x value equal to 0. Notice that I have not moved left or right whatsoever. No horizontal shift. So x is equal to 0. Exactly. So I'm going to plug in 0 for x for both of these. 0 to the third is 0, times 3 is 0, plus 0 squared is 0, times 6 is 0, 0 plus 0 is 0. So my y-intercept is going to be at 0. And that's it. All right, these are the last two questions here. I got this one and one other one, but it's asking the same thing, so I'll do both of them. What it's asking for is the inverse and stating the domain and range of each. So first, let's do the domain and range. This is a rational function. So the parent function looks something like this. Two very important things to note here. We have most likely a horizontal asymptote, and we have most likely a vertical asymptote. I say most likely because it's not always the case, but that's the majority of the time, usually when you deal with these, that's going to be involved. The reason why these are important is because these are going to be restrictions for your domain and range. Notice again, if you have your fellow walking here, they're falling off a cliff. And if you are trying to get down, on some Mission Impossible thing, you ain't making it, right? You're going to have to make this crazy leap, right? It's not going to be a smooth way on the way down. So those are going to be my domain restrictions and my range restrictions. So when it comes to domain and range, what I like to tell people, like to tell my students, is you're not trying to find what the domain is, rather you're trying to find what the domain isn't. What the domain isn't is when the denominator is equal to 0. The reason why is because that's not physically possible, right? Whatever x value makes the denominator equal to 0 is what x physically cannot be, because you're not allowed to divide by 0. How do I figure that out? Well, I just said it, right? Math is a language, right? So all I have to do is translate it. 7x plus 2 cannot equal 0. So, well, that's not a good start. 7x plus 2 equals 0. Why am I doing that? Well, because if I know what it is, I can tell you what it can't be, because it cannot be this. So if I figure out what x is when it makes it 0, there's your vertical asymptote. So I'm going to subtract 2 from both sides. 7x equals negative 2. And I'm going to divide both sides by 7. And I get x equals negative 2 sevenths. That is my, in this case, vertical asymptote, or my domain restriction. So negative infinity to negative 2 over 7 union 2 over 7 negative comma infinity is equal to my domain. Now your question probably is, well, why is it open on that interval, right? Like, why do you have open parentheses there? And why is it this? Well, because there's, like I said, I'm just trying to find when it isn't. So the only time it isn't is negative 2 over 7. And now you're like, why is it not closed? Because it can't actually equal negative 2 over 7. Because if I plug in negative 2 over 7, I get 0. That's not possible. So what the domain is telling you isn't necessarily what it isn't, it's telling you what it is. It's everything that the graph has to equal. So the graph equals everything up to negative 2 over 7 except it on both sides. So I have to put that open interval, right, that open parenthesis there to show you that. I can get as close as possible to negative 2 over 7, but it actually cannot equal the real thing. If I made it closed, then I'm saying in this case that negative 2 over 7 is a valid answer to the graph, but that's not the case. If you look at this graph on Desmos, for example, you'll see I can get infinitely close to that value, but I'll never actually reach that value. All right, now for range, it's the same idea. Range, I'm gonna do the same exact thing. Except now I just gotta find the horizontal asymptote. Well, there's three situations for the horizontal asymptote. There is when the numerator is equal to the denominator, when the numerator is greater than the denominator, and when the numerator is less than the denominator. I'll go through all of these briefly, but if you want a video more in depth on how to do each of these, just let me know in the comments and I'll make that happen. Anytime the numerator is equal to the denominator, in this case it is, because notice what I mean by equal, I'm talking about the highest degree of value. So the highest exponent. So in this case, the highest exponent, well, there's only one variable here, it's x, and they're both to the first, so they're equal to each other. In that case, it's just the coefficients. So actually, in this case, my horizontal asymptote is going to be at 8/7, because I just do the values in front. If the numerator is greater than the denominator, then there is no horizontal asymptote. And in fact, instead, there's a slant asymptote, possibly if the degree of the numerator is only one more. So let's say, for example, if it was this case, then there would be a slant asymptote, and that slant asymptote you find by doing long division. So I would divide this thing, and then I'd find the slant asymptote that way. The last one, which is like the nicest one, is when the numerator is less than the denominator, the horizontal asymptote's at 0. And that intuitively makes sense, because if you think about it, in this case, no matter what x value I plug in, as long as these x values are getting bigger and bigger and bigger, right? This fraction is going to get smaller and smaller and smaller. So the bigger my x values get, the closer I get to 0, which is my horizontal asymptote will be at 0. Nice catch. But in this case, like I said, horizontal asymptote's at 8/7, so my range, just like I did for my domain, is going to be equal to negative infinity to 8/7 union 8/7 to infinity. Next thing here I do is I have to find the inverse. Well, what is the inverse? The inverse, in terms of just technicalities, is a reflection over the y equals x axis, right? So whatever it looks like is going to be the mirror image on the other side of this thing. Algebraically, however, the x and y values are flip-flopped. So let's say right here in this case, let's say this is 3 and 1, then the inverse is going to be at 3, 1. What just happened? Well, notice my x and y value slipped. This point's 1, 3 right here. This point's 3, 1. Same numbers, flip-flopped. So if I want to find the inverse of a function, I do just that. So instead of having this, I'm going to say x is equal to 8y minus 9 over 7y plus 2. Well, from here, all I have to do is solve. This is the inverse. I found it. But now I just have to solve back for y so it looks like a normal function. So what I'm going to do is I'm going to multiply both sides times 7y plus 2. Very important that you remember these steps here, because anytime you're solving for a variable in the denominator, the steps are almost always the exact same, and it's going to be this. You multiply by the denominator on both sides times x equals 8y minus 9. Next thing I'm going to do here is I'm going to distribute the x to both terms. So 7xy plus 2x is equal to 8y minus 9. Now what I'm going to do is I'm going to move all of my x terms and other terms to the right side while moving all my y terms to the left side. So I'm grouping everything up. So in this case, 7xy minus 8y is equal to negative 2x minus 9. From here, what I'm going to do is I'm going to undistribute the y. So the same way that you can multiply a term into parentheses, I can divide it out. So I'm going to take out y. That's going to leave 7x minus 8 equals negative 2x minus 9, all divided by 7x minus 8. And then look at that. When I divided it right there, that's my inverse. Now, the question was then asking, what is the domain and range of this? Now I could theoretically do exactly what I just did all over again, right? Find the vertical asymptote, find the horizontal asymptote, easy enough, it wouldn't take that long. But I don't have to. And the reason why is because remember, like I said, the inverse is just the flip-flop, right? Same thing with domain and range. So what was the domain? Well, the domain was -2/7 was the vertical asymptote, right? So it was negative infinity to -2/7 union -2/7 to infinity. Congratulations, you just found the range. The range of the inverse is going to be the domain of your normal function. So in this case, -infinity to -2/7 union -2/7 to infinity. And that's the same thing with the domain. The domain is also just the flip-flop. So the range for your normal function was, well, your horizontal asymptote was 8/7. So look at that. My domain is then just going to be -infinity to 8/7 union 8/7 to infinity. And if you want to do that, you can just check it yourself. Notice that if I plug in 8/7 here, the 7s cancel out. You get 8 minus 8 equals 0. That's a domain restriction. And notice here, -2/7, those are the coefficients. When the highest degree is equal to each other, that's my range. That's it. All right, round 2 here. F of x is equal to the square root of x plus 5 minus 2. So first thing I'm going to do is I'm going to find the domain and range. So the domain is when this whole function here, well, in this case, it's when this square root function is less than 0. Why? Just like the last one where we did with rational functions, you're not allowed to have that, right? So at that particular value for the rational function, the graph didn't exist. Same thing here. You can't have a negative square root, right? It's not physically possible. So at that particular x value, the graph again doesn't exist. So what I'm going to do is I'm going to say then x plus 5 must be greater than or equal to 0. Right? It's got to be. That's the only thing that's allowed, right? So in this case, x has to be greater than or equal to -5. Well, that's my domain, right? X has to be greater than or equal to -5. Okay, so in that case, my domain has got to be -5, comma infinity. The reason why is because just like I said, right? It's got to be greater than or equal to -5. Anything less than -5, and then I get a negative exponent, which is, well, not a negative exponent, a negative radical, which is imaginary. So there you have it. So for the range, it's a little bit different than the rational function. The reason why is because there is no fraction, right? So I can't do the numerator denominator thing. Instead, I just got to think about this logically. The range is my y values, right? I'm trying to think of what it can't be at its maximum and minimum in terms of y. Well, y is the function itself. So in this case here, again, what can't this equal? Well, x plus 5, again, must not be less than 0, right? That's not physically possible. So in this case here, I'm not going to try to figure out what x has to be. I have to try to figure out what the whole function cannot be equal to. Well, if I know that x plus 5 cannot equal 0, so the square root of x plus 5 must be greater than or equal to 0. Well, if in that case, the whole function, the square root of x plus 5 minus 2, must then be greater than or equal to -2. Because that's the whole thing. As long as this thing has to be greater than 0, then if I just tack on -2 there, if I subtract 2, I'm essentially just subtracting 2 from both sides to keep the equation balanced. That's what my range has to be. My range has got to be greater than or equal to -2. So that will be my range. And notice in this case, I'm putting these closed brackets here. Why? Because 0 is actually allowed here. 0 is a part of it. If I plug in -5, that's okay. -5 plus 5 is 0. The square root of 0 is 0, right? That's an actual point on this graph. The rational one, if I plug that in, it's actually not a point on the graph. In this case, -5 is. That's the difference. Okay, so now I got to find the inverse. So I'm going to flip-flop. X is equal to y plus 5 minus 2. Okay, I'm going to add 2 to both sides. So x plus 2 is greater than or equal to, or x plus 2 equals y plus 5 square root. I'm going to square both sides. That's going to give me y plus 5 is equal to x plus 2 squared. Last thing here, I'm going to subtract 5 from both sides. And the inverse is equal to x plus 2 squared minus 5. There you have it. Now in terms of the domain and range, just like the last one, it's going to be the same thing. I'm just going to flip-flop these. So in this case, the domain of the inverse is going to be equal to -2 infinity, and the range of the inverse is going to be equal to -5 infinity. And that's basically it, guys. If you guys want videos done similar to this on your own type of topics, like your own homework, study guide, etc., feel free to drop those things down in the comments. Other than that, I'll see you guys on the next one. Take care, and as always, peace out.